And from inductance we are going to discuss two topics, that is self-inductance and mutual inductance. So first of all, what is inductance? Whenever the flux linked with a coil is changed with time, then an EMF is induced. So this flux linked with coil is directly proportional to the current which is flowing in the coil. So change in flux or magnetic flux is directly proportional to current flowing through the coil. So phi B is equal to Li. A constant which is introduced here is known as inductance. And what is the SI unit of inductance? It is Henry. It is denoted by Henry. And for unit and dimension, you can do the following, that L is equal to phi B upon I, and phi B is magnetic flux, that is B into a Weber meter square, and I is ampere, so Weber per ampere meter square. This will be the SI unit of inductance, and it is denoted by Henry. Okay, so for self-inductance we are going to discuss in detail that what is self-inductance. So our next topic is self-inductance. Self-inductance क्या होता है? जब किसी कॉइल में जो कॉइल कनेक्ट है बैटरी से और एक स्विच लगा हुआ है, अगर इस कॉइल में करंट नहीं फ्लो कर रही है t इज इक्वल टू 0 पे, उस टाइम कोई भी करंट फ्लो नहीं कर रही है, और अगर हम स्विच को ऑन कर दें, इफ वी आर doing the switch in on position, then what happens? Current start flowing to the coil, and when this current is going to change from time t is equal to 0 to t is equal to t, and EMF is induced due to this change in current, because the magnetic field link with the coil is going to change with time. So from Faraday laws, whenever there is change in the magnetic field linked with the coil, with the area of the coil, that is magnetic flux, then an EMF is induced. So this EMF is induced, or this change in magnetic flux is taking place due to what? Due to change in current. That's why we are saying it as that phi B is proportional to I. Phi B is proportional to I, that is phi B is equal to L. So here we are going to calculate L, that is self-inductance. It is L here. L is self-inductance. So if we see the diagram once again, consider this solenoid of length L. Current I is flowing of battery V volt. Then length of solenoid is L. The total number of turns is capital N. So phi B is equal to B, that is magnetic field into area, and magnetic field produced by this coil, this is solenoid, is mu naught Ni. Okay. So if the single turn is having the change in magnetic flux, then there are n turns. So we have to multiply this flux by n. अगर एक टर्न में फ्लक्स चेंज हो रहा है तो n टर्न्स है वहां पे, तो n टर्न्स में फ्लक्स चेंज होगा, तो n phi B is equal to mu naught Ni. So we have to multiply n both sides, and area will be pi r square of each coil. Of each coil area will be pi r square, because every coil is like a circular coil of radius r. सभी coil का radius r है, और अगर n टर्न्स हैं या n coils हैं तो टोटल जो फ्लक्स लिंक हो जाएगा वो n phi b हो जाएगा। तो जो ba की वैल्यू आएगी उसमें भी किसका मल्टीप्लाई करना पड़ेगा हमें, n का, और n की वैल्यू क्या होगी समझते हैं। Since small n is equal to number of turns per unit length, therefore capital N is equal to small n into L. So क्या लिख सकते हैं यहाँ पे म्यू नॉट n I pi r square into small n into L. So now this equation becomes म्यू नॉट n square L pi r square into r. So let us see that what will be the value of L. N phi b is equal to mu naught n square L pi r square I, and we are comparing with the original equation, that is n phi b is equal to Li. So L can be written as mu naught n square L pi r square. This is the value of self inductance of a solenoid. Okay. If you are any doubt, you can comment in the comment section. Now we are going to start the another topic.